Hello, this is my video covering projectile motion. Now, a projectile is any body that is given an initial velocity that follows a path determined entirely by the effects of gravitational acceleration and air resistance. These two pictures show the trajectory or the path that each projectile follows while in flight. The cool thing about projectile motion is that kinematics equations are used to solve them. And the cool thing about kinematics equations is that they apply to various subjects in physics as long as you have at least three of these components, which are displacement, acceleration, initial and final velocity, and time. Now, for a problem that involves a speed with a theta, you would have to use a trigonometric triangle which uses sine and cosine elements in order to find the vertical and horizontal speeds of each section. Let's try our first problem. A stunt driver is attempting a movie stunt where he must drive a car off a cliff. The initial velocity of the car is 15 meters per second and the height of the cliff is 50 meters. What distance does the car cover? Now, the first thing you always want to do with a projectile motion problem is you always want to write out your horizontal and vertical components. You see, I've already written out the given components that we already have. Now, you can always remember that on the horizontal side, acceleration is always 0, and on the vertical side, acceleration is always negative 9.8 because of gravity's effect on whatever projectile. Also, especially on this, only on these projectile motion problems where a car is driving off a cliff or something is going off of something without an initial speed in horizontal directions, the horizontal direction speed is always a 0. So, to start off this problem, we would have to use our given components and plug them into an equation to solve. The equation I would use is delta x equals VOT plus 1/2 AT squared. Now, by plugging in these components, we can find that since velocity is 0, it would just be delta x equals 1/2 AT squared, and which would give us 50 equals 0.5 times negative 9.8 times t squared, which would give us 50 equals 4.9 times t squared. Now, by dividing 50 by 4.9 and then square rooting the result, you would get the time, which is 3.19 seconds. Now, the cool thing about these problems, since they're all just one exact trajectory, you would have the times they can be equal. So you can use this time for the horizontal time. Now, for the horizontal side, use the same equation, delta x equals VOT plus 1/2 AT squared, which you can use because since acceleration is equal to 0, it would turn that whole side of the equation into 0, which would give us delta x equals just VOT. And since we already have initial velocity, we can just multiply 15 times 3.19, which is the time we already found, and then you will get delta x equals 47.85 meters. So that is the delta x, which is the distance the car covers in its flight. Let's try our second problem. A revolutionary reenactment team demonstrates the firing of a large mortar. The mortar shell is launched with an initial velocity of 45 meters per second and an angle of 30 degrees. If the mortar shell reaches a height of 55 meters, how far will the shell travel? Now, always write your given horizontal and vertical components. Then, since this problem uses initial velocity and a theta, which is 30 degrees, we would have to use 45 sine of 30 to find the vertical initial velocity, and 45 cosine of 30 to find the horizontal initial velocity. Next thing you want to do is always use your kinematics equation. You can either use delta x equals VOT plus 1/2 AT squared, or delta x equals VF plus VO over 2 times t. Now, I would rather use the second one because the first one would involve a quadratic equation, which would make more work. So, using the second one, it would be 50 times 45 sine of 30 horizontal velocity, which plus 0 because VF is always 0 on the horizontal side. So, over 2 times t. Now, doing the math, you would get t equals 4.44 seconds. Now, since this is a problem that involves firing at a certain range where the height is in the middle, you would have the time that it takes to reach this height is half the time it will take to reach the incomplete distance. So, the times for the vertical side is half of the time for the horizontal side. Makes perfect sense. So what you want to do the second time is you can now use delta x equals VOT plus 1/2 AT squared, since you find the time by doubling this time, which would be 8.88 seconds, and then plugging it in to find the answer. So since acceleration is always 0 on the horizontal side, delta x equals VOT plus 0, because acceleration is 0, cancels out everything on that side. So, plugging in your answers, you will get 45 cosine of 30 times 8.88, which would 45 cosine of 30 would be 38.97 times 8.89, sorry, which would equal delta x equals 346.41 meters. Don't forget your SI units, because you'll get taken points off. Now, there's another type of problem which is similar to this problem that I first showed you, but that involves, instead of a car driving off a cliff, a projectile shot off of a cliff into the air. These problems are simple as long as you utilize the techniques I have taught you, and you'll be doing fine on the AP test.